Hello everyone, welcome to Physics Practicals. In today's session, we will be discussing about combination of resistances. We have two parts in it. One is series, the other one is parallel. In today's class, we will be discussing about series. The aim of this experiment is to verify the law of combination of resistances in series using a meter bridge. The apparatus required for this experiment are meter bridge, two different resistors, PUC key, resistance box, jockey, galvanometer and battery. Here the principle involved is, in a balanced Wheatstone network, equivalent resistance in series will be equal to sum of the individual resistances. Moving on to the formula, we have two formula here. One is resistance, R is equal to SL by 100 minus L. In case we are taking this in a meter, it will be 1 minus L. Where S stands for resistance, L stands for balancing length. Second formula, Rs is equals to R1 plus R2. Where R1 and R2 are the individual resistances. Now, let's move on to the circuit diagram. This is how the circuit diagram looks like. Now, this is battery, this is PUC key, this is meter bridge. These are the two individual resistors, galvanometer and a standard resistance box. Starting with the positive terminal of the battery, we are going to connect to the A terminal of the meter bridge. The first gap of the meter bridge is being connected to series combination of the resistor. B terminal is connected to one end of the galvanometer and the other end of the galvanometer is connected to jockey, which runs over the wire. The wire might be magnite or constanta. Now, the second gap is connected to a standard resistance box where we unplug the resistance values. The next terminal, C terminal of the meter bridge, is connected to one end of the PUC key and the other end of the PUC key is connected to negative terminal of the battery. Moving on to the observation, we have two observations. R1 and R2 are the resistances that has to be recorded, which is noted on the resistor coils. Now, coming to the tabular column, we have resistance S in ohms, balancing length L in centimeter and resistance R in ohms. Now, we'll move on to the circuit connection. Now, we'll have a look on apparatus. The first one is meter bridge. This is terminal A, this is terminal B and this is terminal C. This is first gap and this is second gap. We have a scale fixed on it to note down the radius. And this is a constantine wire or a magnite wire. Now, the next thing is battery. It has two terminals. One is positive and the other one is negative. And the range is from 2 to 12 volt. These two are resistance coils and the value is marked on it. This is PUC key, which is used to get a link between the battery and the other apparatus. This is jockey, which is used to run over the wire. This is a galvanometer. It is an instrument used to measure a very feeble current. This is a standard resistance box which ranges from 1 to 100 ohms. Now, the last part which is required is connecting wire. We'll move on to the connection part. Starting with the positive terminal of the battery. The positive terminal of the battery is connected to A terminal of the meter bridge. This is the A terminal. This terminal is left free. We are not going to connect anything here. Now, the first gap of the meter bridge is connected to series combination. series combination is end-to-end connection. I'll just show you now. This is one end. Next, from this end, you need to connect to the other coil. Make sure that you make tight connections so that you get proper readings. Now the other end of 5 volt is connected to the gap. Once you are done with the first gap, move on to the B terminal. This B terminal. B terminal should be connected to galvanometer and jockey. The galvanometer is connected to B terminal. The next end of the galvanometer is connected to jockey. Now, moving to the second gap. Second gap is connected to a resistance box which is having a range of 100 ohms. The values of the resistance is marked on the box. Now, you can go for the last terminal, that is terminal C. This terminal C is connected to one end of the plucky. The other end of the plucky is connected to negative terminal of the battery. The black one represents a negative terminal here. We are done with our circuit connection. We'll start with a reading. The reading, close the plucky and check for opposite deflection in the galvanometer. You can see the opposite deflection in a galvanometer. Similarly, go for the other end and check for the galvanometer deflection. Let's start with the first reading. First, unplug 5 ohms and start moving jockey from terminal A to C until you get a zero deflection in a galvanometer. The galvanometer is showing zero deflection for 64.5. So the first balancing length is 64.5. Now let's move on to the second one. Unplug 6 ohms. 5 plus 1, 6 ohm. Now repeat the trial. Move the jockey until you get a zero deflection in a galvanometer. The galvanometer is showing zero deflection for 59.9. So this is the second balancing length. We'll move on for the third one. I have unplugged 5 plus 2, 7 ohms. Move the jockey on the wire until you get a zero deflection. The galvanometer is showing zero deflection for 57 centimeters. So we are done with 3 trials. Now let's move on to the calculation part. We have recorded the readings in a tabular column. Now we'll move on to the calculation part. We need to calculate R for all the 3 trials using this formula. First one, R1 is equals to, substitute for S, that is 5 ohms, N is 64.5. So 5 into 64.5 divided by 100 minus 64.5. This comes approximately to 9 ohms. Now, the second one, so 6 ohms, the balancing length is 59.9. Calculate R2 now. R2 is equals to 6 into 59.9. So 6 into 59.9 whole divided by 100 minus 59.9. Approximately 8.9 ohms. Coming to the third one, for 7 ohms, we've got 57 centimeter. R3 will be 7 into 57 divided by 100 minus 57. This comes around 9.2 ohms. Now take a mean of all 3 and give the series value. So RS through practical will be 9 plus 8.9 plus 9.2 whole divided by 3. This comes around 9.03 ohms. This is a practical value. Now go for the theoretical one. RS will be equal to R1 plus R2, the theoretical formula. Substitute for R1 and R2 which we got on the coil. That is 5 ohms and 4 ohms. So it is 5 plus 4. It is 9 ohms. Have a look on theoretical and the practical one. Approximately there is a small difference. Approximately it is same. So the law is verified. We have verified the aim of this experiment. Now we'll enter this and we'll end up with the session.